तुम्हारा माइक चालू है?
Sir, good evening, sir.
Good evening, sir. Good evening, sir.
Yeah.
Sir, the participant has to yet to join, sir.
No issue, sir. We can wait. No problem.
Hello, Punita madam.
Yes, sir. Shall I start? Yes, sir.
Yeah, you can start, ma'am. They will join within 1 or 2 minutes. Better you can start because resource person is waiting a long time.
Yes, sir. Yes, sir. Okay, okay.
No issue.
Okay, I'll start, sir.
Yeah.
So, participants, we move forward to session 10. Topic is computational modeling. Now, it gives me a great pleasure to introduce our esteemed resource person, Dr. S. Ravimaran, sir, a distinguished academician, researcher, and administrator with over 28 years of experience in the field of engineering, education, and research. Dr. Ravimaran sir holds a PhD in mobile cloud mining from Anna University, Chennai. He also holds degrees in computer and communication engineering and computer science and engineering. At present, he is serving as the controller of examinations and professor and head of the Department of Artificial Intelligence and Data Science at Saranathan College of Engineering, Trichy. Previously, he served as the principal and professor at MAM College of Engineering for over 2 decades. He has successfully guided 13 PhD scholars, published more than 59 research papers, and secured research grants over worth rupees 37 lakhs from reputed organizations including AICTE, CSIR, and Anna University. He is a fellow of the Institution of Engineers and a life member of CSI and ISTE. He has been honored with several awards, including the Best Facilitated Award from Infosys and the Best Counselor Award from the Computer Society of India. We are truly privileged to have such an accomplished and inspiring academic leader with us today. On behalf of everyone present here, I extend a warm virtual welcome to Dr. S. Ravimaran, sir. Thank you, sir, for joining us and agreeing to share your value. Thank you, sir, for joining us, for sharing your valuable insights.
Thank you, madam. Whether my screen is visible?
Yes, sir, visible.
Yeah, okay. So, respected dignitaries in the virtual mode, all the members of Tagore Engineering College and participants from various engineering colleges, Very good evening to all of you. I think conducting ATAL FDP in the physical mode is itself is a very challenging one. But doing the same thing in online, I think again it is a very big challenge. I think the Nanda College is, Tagore College is holding this event for the last 5 days. Today is the 10th session. I think hats off to the entire organizing team of Tagore Engineering College for getting the approval from ATAL and also doing the same this last 5 days. I also thank the management of Tagore Engineering College for inviting me to be the guest for this session 10. And this topic, the topic is it's also very prominent and is very popular right now. Computational modeling and machine learning for robotics. So the tagline is also very catchy one, shaping the future of digital transformation, right? So just 2 years back, I started the research in this computer modeling, and two of my research scholars doing research in this computational modeling for healthcare system. Okay, but your FDP title is related to robotics, how to enhance the performance of the robotics with the help of machine learning, with the help of the computation modeling, right? So the ultimate aim of this FDP is how to create a sustainable future for digital transformation. So that's why AICTE also sanctioned this kind of FDP to almost all engineering colleges, eligible engineering colleges to all over the India, right? So with this short note, once again, I thank all the management and faculty members of Tagore Engineering College inviting me to be the guest for this session. So I have different parameters to explain. Okay, almost 8 to 9 parameters starting from the introduction to conclusion part, right? Because the computational modeling is not a very small topic, right? It's a hot topic as of now. Almost all domain, starting from transportation, manufacturing, healthcare, education system, robotics, almost all domain require this kind of computational modeling, right? So we have discussed a lot of things in our research forum, and the last 2 years we are doing a lot of works, right? Not a lot of works, very few works in this particular area, right? So in this session for the next 1 hour, I'm trying to give a lot of insights with respect to computational modeling, why it is required, why it is so popular, why almost all domain need this kind of modeling concept, right? I try to convince the audience, right? So that's my ultimate objective of this today's session, right? Before I start this introduction part, I need to give a very small story, right? I think most of you, I think, really understand why story is required for any kind of lecture session, right? So if you tell some story and relates that story with the content, I think it is reach almost all the audience. Okay, so that's why I start with this session with a small story, right? Before getting into the introduction part. Is it clear now?
Yes, sir. Yes, sir.
Thank you. Suppose you are one of the person you really love to packing the cakes, right? You're ready to cook the cakes, right? But every time you tried, something's went wrong. It obviously happened in almost all the home, right? Sometimes the cake was too dry, sometimes the cake was too nasty, right? So definitely you need to try at least 5 to 10 times. Okay, so you need to waste all ingredients, you need to waste your time, you need to waste all the resources available in the home, right? So instead of this, okay, so why don't you think alternative method, right? Without wasting ingredients, without wasting your time, without wasting your resources, so how to make a beautiful cake at the end, right? So that's the ultimate aim. Okay, so instead of wasting ingredients every weekend, okay, you can create a system, a computer system. Okay, you write a small program with the help of machine learning and deep learning concept. You can simulate a packing process in a small environment. Okay, so in that you can enter different values, right? Normally the packing required oven temperature, packing time, amount of butter you need to add, what are the different ingredients to be added. So everything to be clearly specified, right? So instead of doing every time and you get different output, so you write a small program with the help of machine learning, right? And try to change the oven temperature, packing time, amount of butter, amount of sugar, and other ingredients. Okay, so the computer model what you created, okay, showed her a different cake. Maybe it may be under each conditions. Okay, without actually packing it. Okay, so you don't want to cook or packing the particular cake with the computer system with a small amount of data like temperature, time, amount of butter, and amount of all other ingredients. Okay, so if you do the modeling, okay, by doing that's a kind of several simulation, you found that a perfect combination of ingredients at the temperatures, and you can change the temperature every time, and you can change the amount of butter, you can change the amount of sugar. So try to simulate in multiple ways and multiple way time. So what happened? So if you tried first time, you will get maybe a 30% good cake. Okay, so when you simulate the second time by adjusting the temperature and other ingredients level, you will get some 50% of good cake. Okay, so after doing a couple of simulation, okay, definitely at the end, okay, maybe after fifth and sixth simulation part, you will get a exact ingredients and exact cake, right? So after several simulation, you found that the perfect combination of ingredients and temperature, right? So you can finally you can do cook the real cake. It turned out soft and maybe a perfect one. Okay, so without using a proper ingredients, without physical ingredients, without physical resources, without proper resources, okay, with the use of computers, with the use of machine learning algorithm, you can simulate how to create a cake. Okay, so that's why you need a computational part. Okay, so that's the concept of that is the actual scene behind the computational modeling. Okay, I think you can understand the this small story, right? So now you can move on to this introduction part. So the introduction part consists of the three component. Uh, Obviously, it should start with what is computational modeling. Now I need to relate the computational modeling definition with this story, right? We will see. And what are the importance and why you need a simulation for this kind of FDP? Because FDP is completely focused on robotics, right? So why simulation is required for robotic behavior, right? That is the second point. And third one is what is a different kind of role the machine learning can do to create a best robotic system, right? So that's the three important component will be introduced in this first part of the 10th session, right? So most of you are aware that what is computational modeling, right? So now you please remember the story that I was told a couple of minutes before. Now you relate the definition of computational modeling, right? I read out the entire definition so that you can easily understand what is computational modeling, right? Computational modeling is the process of using computers. Okay, so ultimate thing is you are going to use computers for your modeling process. Computers may be anything. Okay, your computer may be your desktop, your laptop, or any computational devices, right? Even we can use quantum computing, right? Any computers, right? For what? To create and analyze mathematical model that simulate a real world system, processes, or phenomena. That's the first one. Okay, you need to create a you use computers to create and analyze what what are the mathematical models you have to simulate the particular real world application. Okay, it helps in understanding and predicting and visualizing the behavior of complex system that may be difficult or impossible to study directly through experiments. So the very crispy definition is computational modeling is a kind of simulation to perform a complex problem or complex task. Okay, if you have a complex problem with you, if you have a complex task with you, that is not possible to do it in a real time in a physical mode, you can do it with the computation modeling. Try to get the outcome of the model, and based on that, you choose the best model and try to implement in a physical way. Okay, so that's the way you need a computational modeling. So that's why all domain in the world, okay, you need a computational modeling so that the resources are saved, the manpower are saved, the cost is also saved. Okay, almost everything is because the entire world is moving towards cost cutting environment, right? So a lot of things will be saved when you do this kind of simulation, this kind of computational modeling, right? So that's a definition. So once again, I repeat the definition. It's a kind of system to simulate a mathematical model for a complex problem. Any complex problem to be solved, to be modeled with the mathematics and with the computer system, right? Suppose you take I will give 2 or 3 examples so that you can easily understand, right? You take the first example related to weather forecasting. So, last 2 to 3 days, we received a lot of forecasting from both the government and as well as from the private agency, right? What government told that Chennai and other regions they told that yesterday, right? Red alert and few areas with orange alert. Okay, but at last, what happened? Nothing was happened. Okay, and but the private agency they told that these all predictions based on the data they received. Okay, but as per they simulated. They created a different kind of computation model, and one of the person he told that definitely there is no that much rain in all these areas they mentioned. Okay, so you need a exact forecasting method. Okay, without any interference or discrepancies. Okay, so in weather forecasting, computational models use mathematical equation to simulate the atmosphere behavior. Okay, so what is the atmosphere behavior? For that, you need different parameters to. Okay, and with that atmosphere behavior, you need to simulate with the help of different softwares. Okay, so that you can get the accurate predictions whether rain will come on a particular day or not, what is the amount of rain will come. So everything you can detect and you can predict by using the computational modeling. Okay, for that you need a support of machine learning, and you need a data collection, you need a different kind of modeling process, you need a different type of testing process, validation process. Okay, so definitely the weather forecasting is one of the beautiful application nowadays because of a lot of the things are implemented. Okay, so for this you need a data from the satellite sensors, and weather stations are fed into these models to predict the future weather condition like rainfall, temperature, or storms. Okay, so this entire application, this computer modeling need data from different sources like satellite sensor and weather station. Okay, and all these data are given to the system. Okay, this here with the weather station we got is a kind of computation model. Okay, once you feed all this information to this weather computation model, okay, this system, this weather computation model will predict the future weather condition, like whether the rain is coming or what is the temperature on tomorrow, and what about the next 5 days. Everything will be predicted with all this data with the proper computational model and with proper algorithm. Okay, so this is a very beautiful example to understand about the computational model, why computational model is required for weather forecasting, right? And other one is nowadays cloud computing is playing a vital role in almost all IT platform, right? There are 3 different components you need to consider in this case, right? One is the consumer, the other one is the cloud, and in between there is another component we call as edge devices. Okay, so last 5 to 10 years, all customer requests are forwarded to the edge computing, edge devices instead of moving everything to the cloud system. Okay, so that the burden of the cloud computing is reduced. Okay, and NASCOM says that by 2030, around 30 billion devices to be connected to the internet. Okay, and if you imagine, right, if all these 30 billion devices are connected to the internet, just to imagine what kind of data will be generated, what amount of data will be generated from all these devices. Okay, and assume that if all these data are moving towards the cloud, definitely cloud will overflow. Okay, so to overcome this problem, already the system, the concept already introduced, that we call as a for computing, right, or edge computing. Okay, so the edge devices will take care of all the requests of the consumer on behalf of the cloud. So the devices will do all kind of data processing, data cleaning, data analysis, right. Once all these processes will be completed, the edge devices need to reconcile with the cloud system, because the cloud is the basic resource system. So you need proper optimization between your edge devices and cloud system, right? So you need a proper computational model. Okay, suppose you are getting some data. Suppose some edge devices get some data from a cloud system and do some kind of process on behalf of the client. Okay, when the process is over, the data processing result will be communicated to the client, and all processing information should be reconciled to the cloud system. Okay, so in this case, uh, how to transfer the data to the cloud, or how to get the data from the cloud is a very challenging one. Okay, so for that you need a proper optimization technique. Okay, so this is not possible to do it in a real time. Okay, accessing the cloud, accessing the edge devices, you need a lot of formalities, you need a lot of legal issues. Okay, so with this, if you want to create a system, it is very highly, it is impossible, right? So instead of that, you create a simulation part. Okay, you create a edge devices simulator and cloud simulation. Okay, and you do some kind of modeling with the support of machine learning, so that the cloud resources available in both locations, that is in cloud or the edge devices, will be properly optimized. Okay, so once you will get a optimization percentage, from that optimization percentage, you can choose the best optimization percentage, and you can you can try to implement the particular system in the environment. Okay, so before getting into the real environment, you can do the modeling and do different kind of simulation and choose the best one. Okay, so that's why the cloud is doing currently, right? A lot of research is going on to optimize the cloud. Okay, with the help of computation modeling. Okay, so that is another real-time example. Okay, in cloud resource optimization, computational modeling is used to simulate and predict how computing resources such as CPU, memory, and storage are utilized across virtual machines or containers. Okay, so containers may be in edge devices or maybe in different platforms. Okay, so how to create a relationship between this virtually, so that you can get to know the optimization percentage. Okay, you can choose the best optimization, and then you can physically you can implement. Okay, so that's why you need a proper computation modeling for optimizing the cloud resources. Okay, so if you do this kind of modeling, definitely this kind of service provide dynamically allocate the resources to ensure low latency, increase the efficiency, and also it reduce the cost and maintain the performance. Okay, so at the end, you need a quality service from the cloud system. Okay, as a consumer, as a customer, I expect that a quality service, a quality from the any kind of real world application, so that we can do it with the support of computational modeling. So this is another example. I think you can easily understand, right? So one is weather forecasting. Why weather forecasting required computational modeling, and the next important the application is cloud computing, because almost all applications running on the top of cloud system. So definitely cloud will overflow. Already it is overflow, but if all devices connected by 2030, okay, so definitely you need alternative system. So already the alternate system is already engaged in the platform in terms of edge or for computing, but you need a proper optimization. For that, you need an effective computation model. So with that computation model, you can do different wonders in the cloud platform, right? So this is an best example why the cloud computation model is required. Okay, and the balancing of cloud load and edge load also is a continuation of the previous example. Okay, so some of the jobs are performed at edge devices and few jobs are performed at the cloud system, but you need a proper relation or proper reconciliation between the cloud and edge, and you need a proper load balancing also to be ensured. Okay, suppose the cloud is currently it is overloaded, and how this load will be given to the different devices, edge devices. Okay, or if the cloud is free, okay, without transforming the load to the edge devices, how the cloud can perform. Okay, for that you need a different computational modeling. You do the modeling with cloud, without cloud, and do the same kind of modeling with the existence of edge devices and cloud devices, or you can do it with the only with the edge devices. Okay, do different kind of simulation with a different kind of scenario so that you will get multiple outcome. Okay, with that you can choose the best one and try to implement. Okay, so that's why all scientists and all engineers need a kind of computational modeling for any kind of applications, right? For any domain. So this is another example for why really computational model is required, right? And another example related to the topic, right? Because for FDPs completely focus on robotic system. Okay, so how this computation model will help to create a better robotic system? Okay, how to ensure the motion of the robot, how it will move in what direction. So all the direction and perception will be detected with the help of the computational modeling, so that you will prepare best embedded system maybe at the end. Okay, so the model predict the robot's path, avoid obstacles, and optimizes movement using algorithm like kinematics and dynamic modeling. Okay, so when you talk about the robots, okay, you need to find out the path. You need to find out what are the different obstacles along with the path, and how to optimize the movement. Right? Suppose you are going to install a robot in a particular room. Okay, in a room, you imagine that there are two bureau. One bureau is having a multiple hard disk, and the other bureau is empty. Now, the task is we need to move all the hard disk in a particular bureau to another bureau. Okay, for that you need to implement or you need to install some kind of robot. Okay, so for that you need an effective computation modeling. Okay, before creating an actual robot, you create a simulated robot. Okay, and try to test how this will be happening in real time. Test with multiple cases, test with multiple input, and test with multiple models so that you can choose the best model for this kind of scenario, right? So in robot motion planning, computational model is used to simulate how a robot will move in its environment before actual implementation. Okay, because environment is one of the important key component for robotic robots. Okay, because the environment play a vital role for identifying the path and predict the path and avoid the obstacles. Everything is very important with respect to the environment. Okay, so the environment play a key role. Okay, so that you can simulate and you can see what happened. Okay, so once you are convinced with the model, okay, you try to implement in a real location. Okay, so that is another example for why computational model is required in a in the case of robot implementation. Okay, so these are the three examples that related to the computational modeling. So we started with what is computational modeling, a real-time example, why all these real-time examples need computational modeling. Okay, so then now we move on to the second component of the introduction part related to the FDP topic, right? The importance in simulating robotic behavior, right? So normally the importance why the robotic need a proper simulation before going to the real physical location. There are multiple points are pointed presented here. I try to cover a few points so that you can understand why the simulation is required for robotics, why so important for robotic to detect the robotic behavior, right? So the one is the safe testing environment. The second one is cost and time efficiency, performance optimization, predicting real world behavior, design and algorithm validation, and scalability and flexibility. So this is only very six. We have listed only six importance. Okay, but if you look into the real world, okay, the importance of simulation is is n numbers. Okay, so we'll go with one by one. Okay, why robotic need a proper simulation, computation, modeling, right? The first reason is you need to create a safe environment for moving. Can take the robot to the particular environment. Okay, suppose you the purpose of this why the safe testing is required is it prevents the damage to robots and surroundings during the experimentation. When you do that experimentation, it always it try to prevent damage, what kind of damage will happen to the robot and what kind of damage will happen to the surroundings. So all will be predicted when you do the simulation. Okay, so that it is important. Simulation, computation model is required for robotics. Okay, self and safe testing environment is one of the importance for a computational model for to detect the robotic behavior. Okay, the second one to reduce the cost and time. Okay, I have to improve the efficiency of the cost and time. Okay, if you consider this point, it reduces the need for building multiple prototypes and performing repeated physical trials. Okay, if there is no simulation, if there is no computation model, right? You need to create multiple robots. You need to test multiple times. So what happened? You need to do the same task repeatedly until you get a better robotic system. Okay. So if you do the simulation, so definitely this will reduce the need for building multiple prototypes. Okay. You can create a modeling. Okay. From that modeling, you can choose the best prototype. That prototype will be implemented at the end. Okay. So that the cost and time efficiency is one of the key element for creating simulation for robotic systems, right? That is the second one. And third one is you need to optimize the performance, right? Because robotic environment, robotic system involves multiple things. It include environment, it include path, it include various devices, it include sensors. Okay, it includes various objects. All these to be properly optimized to get a better robotic system. Okay, so that you need a proper optimization. Okay, if you do it in a physical trial, definitely this optimization you will not get it. Okay, if you do it in a simulation part, if you do it in a computational model, definitely your performance will be optimized. You will get a better optimization without wasting all these resources, right? So the ultimate aim of the optimization is to enhance the speed and precision. Right? The precision of the robot is very important, and energy efficiency of the robot is also important because one of the again key issue with robotic is battery, right? So energy is one of the important element for operation of the robot. Okay, so how far you can efficiently you can use the energy of the robot so that your performance will be properly optimized. Okay, so for that, instead of doing a physical trial, you go with a simulation model so that you will get a better model. You will choose the best prototype for your particular robotic system. Okay, so for that you need a simulation. And fourth one is predict the real world behavior. Okay, if you do it in a physical mode, you should, if you want to predict multiple behavior, you need to do the physical trial for 5 to 6 times or n number of times. Okay, so doing the physical trial n number of times, I think it is waste of the time. Okay, because nowadays the entire world is moving towards computational part. Okay, almost all application need support of cloud computer, support of proper devices and need a proper communication system, right? So definitely the system, the robotic system need to predict the real world behavior without doing a physical trial. Okay, so for that you need a kind of a computational simulation part. Okay, so that will anticipate how robots will perform under real environment conditions. Okay, suppose some obstacles in the path. Okay, that time how the robot will react. Okay, suppose there is a change in the path, how the robot will act. Suppose somebody change the object located in a particular place to the another place. In such situation, how the robot will act. All this you can do it with the simulation. You can virtually you can see what happened when you change the different parameters. Okay, without doing it in a physical mode. So that you need a proper simulation for robotic system. So predicting real world behavior is one of the key important element for this kind of applications. Okay, And the fifth one is you need to design an algorithm for the particular robotics. So what is the purpose of robot? That is also is very important. Whether the robot is going to do this kind of moving parts from one bureau to another bureau, or it is kind of it's a kind of service to the consumer. It depends on the application. Okay, for any kind of robotic application, you need a proper design and you need a proper algorithm. So that should be properly validated. Okay, so instead of do it in the physical mode, okay, you try with multiple algorithm, try with multiple design. Suppose to get a perfect robotic system, if you need a 100 design and 100 algorithm, complete is a waste, right? It's a waste of time. The human resources are waste, the computation resources are waste, the communication resources are waste. Okay, so instead of that, you do it in a simulation mode with multiple design, multiple algorithm, right? Without real environment. Okay, so you will get a lot of benefits. Okay, engineers can test and validate robotic design, sensors, and control algorithm to ensure they function as intended. What you expect should be delivered at the end. For that, this kind of simulation required always required for best design, best algorithm validations. Okay, so this will ensure that robot design and control algorithm works correctly before physical implementation. Okay, so that is the fifth important in simulating robotic behavior. And the last one is scalability and flexibility. That is obviously it is common to almost all application. Okay, you can add any number of robots to the environment. When you add more number of robots, what kind of changes will happening in the path selection, what kind of resource selection to be done. So all this to be need to be considered. If you do it in a physical mode, definitely the cost involved in that normally it is huge, very very huge, right? So instead of that, you do it's a kind of simulation with the support of a computer and machine learning algorithm. Definitely, this enabled testing of multi-robot system and complex coordination tasks efficiently. Okay, so in general, the computational model required to solve the complex problem. Okay, so robotics is a kind of complex problem. I think most of the participants in this virtual meeting, they know, right, why it is very complex. Okay, so because of all these six important reasons, you need a proper computational model for robotics, right? So this is a second topic, and the third component from the introduction part is role in enabling the machine learning system. Okay, so far we discussed about why computation model is required. We discussed different real-time examples, and then we discussed what are the importance of computational model to create a amazing robot. Okay. Now, what is the role of a machine learning system? Why the machine learning system is required to do the modeling, right? So, computational modeling plays a vital role in designing, training, and improving machine learning system by providing a virtual data-driven environment. Okay. So, again, I repeat, it is not a physical role that the computational model plays. It is a virtual role, always done it in a simulation environment for creating a good design, to create a best environment for the particular task. Okay, so that they call it as a create a virtual data driven environment to test, predict, and optimize algorithm before deployment. Okay, so before deploy the original product, original not only this robotics, any kind of application, any kind of product. Okay, so before you deploy the product to the particular real world environment, you try to do it in a virtual mode with the support of machine learning, with the support of different data, and you test and predict and optimize the best one, and then you go for the physical deployment. Okay, so that's why you need a proper machine learning algorithm, right? So I think most of you are aware what are the different machine learning algorithm available, right? Supervised and unsupervised algorithm, and this entire computational model need is a kind of reinforcement learning. Okay, so with the what is reinforcement learning? Okay, you can reinforce, you can create a new environment for the particular task, so that the resources will be saved, and you can do the best testing platform, you can do the best prediction, and you can go with the best optimization system, right? So the The key roles played in the particular machine learning algorithm are one is the data generation, and then you need to simulate the data. You need a proper algorithm to test and validate the algorithm with the proper data, and you need to optimize the performance at the end. Optimization means you create multiple models, choose the best model. For that, you need a optimization and understanding the complex system involved in the particular environment. And finally, you can bridge the simulation real world deployment. Okay, so what is the outcome of this simulation? And choose the best simulation and deploy the same thing to the real world application or real world environment, so that you will get a better product at the end. Okay, so that's why you need a support of machine learning system. Okay, so with respect to data generation, computation model can generate large amount of realistic and synthetic data for training ML algorithms. I think you are aware of this, especially when real data is limited or costly to collect, because data is not taken from only one single place, because the sources of data are multiple. The format, the type of the data are also different. So nowadays, the data is not only text oriented, so data are visual data, image data, video data, audio data. All these data are collected from multiple sources. Okay, so collecting the data itself is a very big task when you do the computational modeling. Okay, so definitely the machine learning need a proper method to collect the data from proper sources, so that your prediction, your simulation, and your modeling will be better. Okay, so that the first part is data generation and simulation is play a vital role in the machine learning part. Okay. The other one is algorithm testing and validation. So model allows safe testing of ML algorithm under controlled and repeatable virtual conditions. So normally you need different simulation models, and you need a different condition. Under each condition, how the model will reflect and will react, that also need to be tested with a proper algorithm, and with the all algorithms should be validated for the reality. Okay, that is also very important. So the algorithm testing and validation is also a key role in enabling the machine learning system. Okay, so if you take a healthcare system, computational models simulate human organs or diseases progress. Okay, so what is the progress of disease, and what about the status of the organs of the humans? So if you want to simulate this kind of application, especially in healthcare, it enabling the validation of ML model for diagnosis without risking patient safety. Okay, so just imagine if I'm going to do the entire testing. Okay, with the real world scenario, definitely no patient will accept. Okay, so you need a kind of simulation platform. In that you can do all these kind of testing. Definitely, this will give a different kind of dimension for the engineers and the scientists. Okay, so definitely the system computation model need machine learning algorithm, and it should be properly validated. Okay, and performance optimization, as we discussed, optimization is always important. Once your system is ready, once the simulation is ready, once the model is ready, the performance all need to be checked for the optimization purpose, so that the better utilization of the resources will be ensured. Okay, and the understanding the complex system also is again is critical role. It provide insights into how inputs influences output, supporting ML model interoperability. Okay, so nowadays the systems are working on the different platform. Okay, different softwares, different hardware, different operating systems, right? Even in robotics use a separate operating system, RTOS, right? So how all these operatives are incorporated with each other, cooperate with each other, and provide a better environment for providing a better system at the end. Okay, so that's why you need a proper understanding of the particular problem. Based on the problem understanding, you need to prepare a virtual simulation area, virtual platform to test all these things. Okay, it means how to generate data, how to simulate the data, how to test the algorithm, how to validate the algorithm, how to create a model, how to write a code for the particular algorithm. Everything to be checked only based on the amount of complexity involved in the particular problem, right? So that is very important. And finally, as we discussed, once everything is ready, as an engineer, as a data scientist, as a computational modelist. Okay, you need to bridge how this simulation will be mapped into the real world deployment. So that is very important. Okay, all these five key points are very important. Even if you are good in one key roles, you will get a lot of jobs. Okay. For both faculty and as well as students. So don't focus on all the key roles played by machine learning in the computation models. Okay, so focus at least one role. How to create, how to collect the data, how to simulate the data. Okay, if you are good in this, you will get a lot of scope. Okay, so focus on almost all the key roles. Right? At least as a faculty, you should have a knowledge on all these five roles so that you can deliver the same thing to the students, so that students can understand the importance of computation model in the current scenario, right? So that is the another point I need to stress in this forum, right? And role of machine learning in robotics that we already discussed, enable robots to perceive, plan, and act intelligently. Okay, so that is very important. You can create any kind of simulation. Okay, there is a concept. Suppose you take one more example. Suppose India is going to play a match, cricket match against Pakistan, probably in the month of February 2026. Okay, just imagine the selection team need to select the best team from the squad members. Okay, assume that there are 20 members in the squad. From that, the team, uh, committee members of the BCCI, right, they need to select the best team for the particular match, so that the winning probability will be increased. Okay, so if you do it in a manual process, they choose some randomly, they can choose the player and they can form a team, and if this particular team will go and play against Pakistan, the probability of winning is you cannot predict. Okay, if it is in a physical platform. Okay, so instead of that, you can do some kind of computational modeling, simulation. Okay, with the help of machine learning with the different kind of inputs. Okay, so if you take Indian players, how many members that you feed all the player data, history of the game, and the environmental condition of the ground, where they are going to play. If it is a February 2026, what about the which location, what about the environmental conditions, and what about the winning combination of India and Pakistan? Everything to be detected, and everything, all data to be fit into the system, and system need to create multiple models and give different simulation output. Okay, suppose the first model provide team one. Okay, the team, if the India go with the team one, the possibility of winning is 30-50. That is 30% is winning and 50% maybe probability for winning by Pakistan. Okay, if you try with by adjusting the different parameters of this particular scenario, if you create a second simulation and if you create a second model, and that model ensure that 50-50 winning probability, and that is also not good. Okay, because 50-50 is not a good probability for a winning strategy. Okay, you try with changing the variable, changing the text input, and create a third simulation model. And if this third simulation model provide 80-20, okay, that is 80% for India and 20% for Pakistan, definitely this model, this simulation model is good model. With this model, the team will select the team 3 for the best model for playing a cricket against Pakistan. Okay, so for any application, you need a computation model so that the prediction and the winning probability and the final outcome of the product and final outcome of any task will be a much faster, much better accuracy, right? So that's why you need a proper plan, and you need an intelligent system, intelligent virtual computational model system for all kind of domains. Okay, and this model provide a mathematical foundation. Okay, because obviously this computation model need a mathematical stuff. Okay, if you are good in algebra and all statistical foundations. Okay, and if you are good in coding, especially in Python and all other coding technique, you will create a wonderful environment for any kind of application in the real world, right? So that's why you need a proper modeling system. Okay, So predicting object movement for robotic grasping. If you take this FDP, because FDP, as I told you, it is focused on the robotic system. Okay, so how to predict the movement of the robotic, right? So for that you need a support of machine learning. Without that, I think it is very difficult. Okay, and role of machine learning. So it do a lot of things. Perception and sensing, motion planning and control, and object recognition, manipulation, human-robot interaction, learning from experience, predictive maintenance, and fault detections. All these are the key roles. Again, when you talk about the machine learning concept for computational model. Okay, so perception and environmental understanding. So if you take perception, right? So machine learning enabled robots to process sensor data that will collect it from the cameras and from various sources to understand the surroundings. So from which area all these data are collected, in under what circumstances. So that perception should be properly analyzed, should understand properly, so that the system will be create a better output. Okay, so it improves this perception and environmental understanding. It always improves the object detection, scene recognition, and navigation accuracy. Okay, so very all these three components are very important. Okay, you need to recognize the scene, and you need to understand the accuracy of the navigation process. You need to understand the what are the different objects in between the path. So all should be need to be understand. Okay, and motion planning and control is also play a important role when you talk about machine learning concept. Okay, it helps the robots plan optimal path and control their movements in dynamic environment. Okay, so Boston Dynamic. Boston Dynamic is one of the popular organization to create mobile robots. Okay, so instead of consider the static robotics system, you go for a mobile kind of robotic system, because it is very popular, and future is completely rely on a mobile kind of robotic system. Okay, so for that you need motion planning and control system. So with the help of proper machine learning, you can define, you can find out the optimal path, and with the help of the optimal path you can control the movement in the dynamic environment. Even if the robot change its path, okay, dynamically it should be relocated. Okay, you consider the example of traffic movement in the Google Map. Okay, so that's the best example for best example for this kind of applications. Okay, so object recognition manipulation is also it's a key role. Robots use ML to recognize the object and manipulate the object with varying shapes and sizes. Okay, so because objects are not in the same size, it may be different, it may be a different size, it may be a different scenario. Okay, so all should be recognized, all should be understandable by the system, so that it will create a better visual environment for the particular application. Okay, Boston Dynamic that we already discussed, one of the popular organization in US to create a mobile kind of robotic system that always use in recent years they use reinforcement learning to maintain the balance and plan complex complex function. Means how the robot will jump, how the robot will run with multiple direction, and when all this will be happening in a dynamic mode. That is very important. Okay, dynamic and real time. Okay, so if we do it in a physical mode, definitely as I told, a lot of things will be maybe in a different shape. Okay, so do it in a simulation mode, and then you go for a real deployment, so that you get a better system, better application for the particular application. Okay, and the human robot interaction is also very a crucial one, right? So you need a proper machine learning algorithm to enable the robot to understand the human speech. Okay, NLP. Okay, Alexa, Alexa is the best example for natural language processing. Okay, so the pronunciation and the language what you are using, everything is important for this kind of computational model. Okay, so for that you need an effective machine learning algorithm to understand the human speech, gestures, and emotion for effective communications. Okay, without understanding the human speech, without understanding the human gesture, without understanding the emotion, of the individual. If you're creating the simulation model, that will not give a proper output at the end. Okay, so human robot interaction is very, very important when you consider when you talk about the machine learning. So machine learning is required to understand all these three things. In this way, you need to train the computation. In this way, you need to train the model. Okay, so human robot interaction is a key role when you talk about machine learning, right? And learning from experience, so that you need a reinforcement learning. Okay, continuously you need to feed the data to the system or to the particular computational model, so that robot learn optimal behavior by trial and error method, improving the performance over the time. Okay, initially start with some basic input, and it gives some kind of simulation result. Okay, then you adjust some parameter, then you get a second simulation. So in that way, if you try with the trial and error method, so at particular point you will get the perfect system from the computational model. Okay, for that you need a learning. Okay, so continuous learning of the system with the support of machine learning is a key role for doing this kind of process. Okay, and predictive maintenance and fault detections also required. Okay, if anything goes wrong when finding the path, while finding the gesture, and while finding the human speech and emotions, definitely you need an effective dynamic system to accept the changes. Okay, so for that you need a fault detection method, and you need a proper predictive maintenance system. Okay, so these are the key roles always considered for machine learning algorithm required for computational model. Okay, and third important thing is, what are the different components of the computational model? So there are different components, but in general, these are the three components: a mathematical model, statistical model, data-driven models. Okay, so with these models, we can create, depending upon the application, you can choose mathematical model. Depending on the application, you can choose statistical or data-driven model. But some application need both mathematical model and statistical model. For some application, you need all the three models. Okay, it depends on the application, depends on the domain, it depends on the scenario, right? So this is the diagrammatical representation of the components of the computational modeling. Okay, so you start with mathematical modeling. You have a complex function, so that complex function should be represented as a mathematical model. Okay, with the help of statistical and algebra functions. Okay, and all these information should be given as an input. And then you need a proper machine learning algorithm that we call as a computational algorithm. The computational algorithm will collect all the mathematical input, and you do the kind of process. Okay, then it is given to the simulation environment. In that, the modeling play a vital role. Okay, so the simulation provide different models with the help of the proper computational algorithm with the proper mathematical input. Okay, and output will be different simulation model. From that, you need to validate, and you need to verify the best model and choose the best simulation model for your final task. Okay, so now the right hand side, how this mathematical model and all three models, there is a mathematical model, statistical model, data-driven models, are mapped with the component of this computational modeling. Okay, if you take mathematical modeling, mathematical models normally consist of equation of motion, kinematics. Okay, all this equation are different mathematical equation, kinematic complex functions, overall feed as an input. Okay, and computational algorithm is related to the statistical model. You need a probabilistic reasoning, you need a different networking algorithm, right? Maybe probably we can Bayesian network. All these will be useful for processing the mathematical equation. Okay, and the last one, simulation and validation and output. All these three components need proper data-driven models. Okay, so for that you need a neural network concept, regression models. Okay, with the help of a neural network model and regression models, you can do you can set up the simulation environment. You can get a different output, and you can do the validation, and you can do the verifications. Okay, so what are the different components? How all these components are mapped with the three different models are given or represented in this image. So this is a comparison of all these three model, the component diagram, how this each component represents the diagrams are mapped into the corresponding model. If you take a mathematical model, it is a corresponding model type is mathematical model. So maybe it's probably it's an equation of motion, equation of the kinematics. Okay. If you take the second parameter, computational algorithm, it related to both statistical and data-driven models. Okay. Examples are given. Bayesian networks and neural networks are some examples are related to the statistical and data-driven models. Input data is common to all. Okay. Because all inputs are relevant to all model types, and simulation environments is common to all, and output and validation also common to all. Okay, and the simulation environment you can use MATLAB, Python, Simulink for create a better models. Okay, and for input data you can get experiment data, observational data from various sources that we already discussed, and finally you need to compare all the results, all the models, and choose the best output. Okay, for your result. So this is a different component of the computational model. So model types in robotic machine learning: the physical model, cognitive model, hybrid model. This is another version of model type. Okay. So physical model, how to simulate real world dynamics. A lot of complex real world applications are there. How it will be simulated in a physical model. For that, you needed to create a computational model. And cognitive models mimic the human learning. Okay, so normally AI is normally it mimic the human intelligence. Okay, similarly the cognitive models mimic the human learnings in the particular environment. Hybrid model is a combination of both physical and cognitive model. Nowadays, hybrid model is very popular because it need both the physical touch and human touch. Okay, so that's why the hybrid model is very popular nowadays. Okay, suppose if you take a physical model, this model use physical based equation to simulate the robot motion, dynamics, and interaction with the environment. Okay, to predict and control robot behavior based on the known physical laws, for example, Newton laws, kinematics, and dynamics laws, you need to detect the physical behavior of the particular robot. Example, you can list out a few things: modeling a robot arms, joint torque and velocities, simulating robot dynamics in a particular environment, calculating the path trajectories using the equation of the motion. Okay, all are the very important component when you talk about the physical equation for the particular robotic system. Okay, so the advantage of physical model is accurate when physics is well understood. Okay, interpretable and stable. That is also is another key advantage of this kind of physical model. But the limitation is may not capture unmodeled effect like friction, sensor noise, complex real world application, because normally sensors provide some kind of noise when you collect data from all these sensors. Okay, so this kind of noise will not be detected when you go with the physical kind of model. Okay, so that is a limitation with the physical model. If you go with the cognitive model, okay, it provide it allows robots to learn from the experience and adapt new situation. Okay, suppose you already define one path. The robot is already traveling in a path. Okay, suddenly if you change the path, it should adapt. So system should adapt the change, and based on that, you need the system to adopt the new environment and give a proper output. Okay, that is also important. For that, you need a cognitive models. Okay, so it gives a robot as a kind of reasoning, planning, and adaptive behavior similar to human cognitive levels. Okay, so the once you create a cognitive kind of computational model, it provide proper reasoning, it provide a proper planning, and it adapt all kind of changes to the particular environment. Okay, so it need a proper reinforcement learning, it need a proper neural network mimicking, and robots learning task through demonstrations. Okay, the advantage of this kind of cognitive models are adaptive and self-improving. Okay, it adapt to any kind of situation. It also improve the performance of the system. Okay, and it also handles uncertainty. If something is goes wrong, if something is different, okay, the system need to adapt, so that without interference, the particular task will be completed particularly by the particular robot systems. Okay, so this is another advantage of using cognitive models. So there are some positives, there are some negative in both models. So if you club both physical and cognitive model, you'll get a better system. So that you need a hybrid model. So hybrid model provide the touch of human, the touch of real world dynamics. Okay, so that's why you need is a kind of hybrid model, kind of computation model. Okay, so this is the comparison of all the three models. Okay. Sir? Hello?
Hello, sir. Tell me.
Can I take another 10 to 15 minutes? Any issues?
Okay, sir. Okay, sir.
Because I have a couple of videos.
Okay,
Okay.
sir.
I tried to play before winding the session.
No
Right?
issue, sir.
Okay, sir. So, what is the flow for a computation? When you create a computational simulation model, what are the different steps to be followed? Okay, it is normally in any data science platform. These are the basic steps to need to be followed. The same thing to be followed here also. One is a data collection, model to be designed, and you need to do that simulation with the support of machine learning, proper machine learning algorithm, and you need to do the kind of best training, and you need to validate and deployment at the end. Okay, so all these three need all these four is required for a proper computation modeling. Okay, so that's why they call it as a workflow. Okay. So problem definition, model formulation, model implementation, simulation and execution, analysis of result, validation and verification, refinement and optimization, application predictions. So multiple steps to ensure the best outcome. Okay. So problem definition. So a problem should be clearly defined. Real world problem should be clearly defined so that you will create a best system for the particular applications. Okay. So clearly identify the real world system, a real world application, a real world process to be modeled. Okay, define the objectives, scope, assumption, and constraints. So this is the first step. Okay, when you define the problem, what is the problem? What is the objective of the problem? What is the scope of the problem? What is the assumption of the problem? What are the different constraints to be considered for the particular problem? So all these key parameters to be considered when you define a problem. Okay, when you look into the model formulation, okay, once your problem is neat and when your problem is clear, you can go for a formulation of a model. Okay, develop a mathematical or conceptual representation of the system. As I told you, need a proper mathematical system with a proper mathematical background. So choose a physical model or a statistical model, or you can go with a data-driven model. Okay, based on the requirement, you can choose any one of the model so that you can derive better equation of the motion or regression relationship from the particular model. Okay, so that's why the model formulation is important for the computation. And once a model is ready, okay, with the proper mathematical or conceptual representation, you go for the implementation part. Okay, that is the third steps you need to consider. So translate the formulated model into the computational form, because all models are currently it is in the form of different shape or different situation that should be converted into the computational form, so that the machine learning algorithm can understand the model and it do the is fine tuning the model and it give a proper simulation result. Okay, so use numerical method or algorithm for solving the equation. Select tools or software to do the implementation of your models. Okay, for that you can use MATLAB or Python and SOL. Okay, all these are popular tools currently available in the computational model to perform a implementation of your model with the support of mathematical equations. Okay, once a model is implemented, you need to create a simulation part. Right? So run the computation model using the input data and parameters. So you have a multiple models. Give some input and check what is the output. Okay, change the input parameter and again check the output. So likewise, you do it multiple time and get the multiple simulation output, and from that you can verify and you can do the validation, and then you can select the best method or best simulation type or best prototype for your task. Okay, so that's why after the simulation, the result should be analyzed. Okay, after the analysis, you need a proper verification validation. So a lot of tools are available nowadays to verify and to validate. Validation means whether the output of the simulated result is matched with the expectation of the application or the customer, right? So that part we call as validation part. Okay, any system should be validated at the end. Okay, and you need to, if your validation is not good, if the verification is not suitable for the particular situation, you need to do the modeling again. You get the proper refinement and come up with a better simulation part. Okay, so that's why you can create a better computational model for the particular application, right? So there are different case studies. So far we discussed about five different things. Start with introduction, then we see some examples. Then what is the role of machine learning in creating a computational model, and what about the computational model flow? How to go with the system? Okay, what is the first step? What is the second step? So all this we discussed so far. Okay, we'll see some case study from the Boston Dynamics. Okay, so as I told earlier, Boston Dynamics is one of the very premier institution, a premier organization to create a mobile-based robotic system. Okay, so it create a dynamic balance through computational models, and it support reinforcement learning system, and it create a best simulation model to reduce the real-world testing risk. Okay, so that is ultimate aim. If you do it in a real world, there are a lot of risks are there. If you want to remove all this risk, you go with simulation part. Okay, for that, a lot of case studies already posted in the Boston website. We will see some example. I try to play some video so that you can understand. Whether the video is playing?
No, sir.
No, sir. We're,
No. 1 minute, please. I will stop and again share. Is it okay?
Yeah, sir.
yes, sir. Yes.
Yes. So this kind of simulation provide how the robot will walk and run and do is a kind of motion. So again, start from the beginning.
No video is playing, sir.
Yes, 1 minute, sir, please.
Yes, sir, no problem.
Now, is it okay?
No, sir, not visible.
1 minute.
Yes, now, yes, sir, now it's visible.
I need to play.
Yes.
Play is not working now. 1 minute.
विदाउट वीडियो पे दे जाएगी
Yeah, 1 minute,
आगे
please.
क्या होने वाला है होने चालू होगा ये
Now it is okay. Is it working? So it involves almost all kind of motion, right? Run, walk, crawl, dive. Yeah. So this is from credits to RAI, and we'll see one more video. So that will do how the reinforcement learning implemented in computational modeling. Is it playing now?
Playing, sir. Audio is not audible.
Hello?
Video is playing, sir. Audio is not audible.
Oh, this is also good. Anyway, we'll see.
There is no sound, sir.
But my volume is only in high condition, but I don't know why it's not coming.
There is no voice, sir.
Voice is not playing, right?
Yes.
So, 1 minute.
Only robot is moving here there. It's good.
Anyway, I think some problem in audio. Okay. Anyway, I will share it with the organizer, both PPT and videos, so that you can go through the videos and you can.
You are requested to kindly share your PPTs also.
Yeah, 1 minute, please. Is it okay now? Is it visible?
No.
One. Okay.
Yes, visible.
Yeah, right. And one more before that, the last video, if it is good, I think we'll play.
Future direction क्या है? No, from the computing of stone. Current sources AI, GPU, printers,
Yeah,
programming,
yeah.
audio.
Sometime when you do it in online, I think it will create some kind of nonsense. I think this one is something is different. You can see this one. I think it will give both path detection and how to change the path. When path is changed, how the robot will react. Yeah, let me see. Is it visible now?
Visible, sir. Visible.
Yeah. Just to see the movement of robot. As I mentioned earlier, right? There are two set of bureaus, maybe Alamar. So the task of robots need to take the object from one bureau to put it in another one. Okay, in a proper location and proper dimension. Okay. Now it's put it in the 15th slot. Just to see what happened now. When it come back, there is an obstacle. There is a human. You take that particular object and put it in a floor. So immediately this will be detected by the robot. Okay. For this case, reinforcement is required. Okay. Before reinforcement, we use only the machine learning algorithm. It provides only the it's a kind of object detection. That's all. Okay. It never understand the change in the environment. See, it understand something is goes wrong. Immediately it turn back. Yeah. Thank you. Thank you. I think you witnessed with a few demos. So the one more point I need to share in this forum. Okay, computational modeling and digital transformation is a ultimate objective of this particular transformation. So how to bridges artificial intelligence, IoT, and robotics, as I told in the beginning, right? By 2030, around 30 to 50 billion devices to be connected to the internet. Okay, when all these devices connect to the internet, the amount of data, the amount of volume of data generated from all the devices need to be properly mapped with the different kind of devices. For that, AI need to do a lot of things. Okay. Uh, so how to bridge all these kind of changes to be happen in the future in both general environment or in the robotics environment, enables adaptive and smart system, and how to adapt to the industry 4.0 and beyond. Okay, so right now we are in the industry 4.0. So probably in another 2 or 3 years we will get different version, right? So that also to be considered. Computation model and digital transformation, so how to integrate the artificial intelligence, how to facilitate the adaptive self-optimization system, and how to create a core enabler for industry 4.0 paradigms. Okay, so conclusion is you can use different tools before conclude. I need to share a few information with respect to tools used for machine learning modeling. Okay, so you can use TensorFlow and PyTorch for machine learning modeling, and for robot operating system you can use middleware framework, and for simulation environment you can use Gasipo, MATLAB, and Simulink. Okay, so three different environment. For all these three environment, different tools are available. Make use of all these tools and create a best computational model and best computational simulation model for a particular application. Okay, so for in a nutshell, the computational modeling is equal to backbone of ML-driven robotics. Okay, you need a proper machine learning-driven robotics that will leads to a proper computational modeling at the end. So drives industrial and digital innovation. The smarter and model will give a smarter robot. Okay, so the purpose of this session provide how to create a best computational model for the particular application, so that the different things considered will be considered, and all these things will be without wastage of all these resources. We can create a best system, better system for the future IT environment. So with this, I hope I share a few of the insights on the computational modeling. I think this 1.5 hours is not enough to cover all the insights. Okay. Because we never talk about the mathematical equation, we never talk about the actual machine learning algorithm involved in the particular environment. Okay, it take long time, right? I try to share some of the books, some of the forum to discuss about the computation modeling. Okay, so probably tomorrow morning I will share it with the organizer, so that all the participants will get all the materials and all the reference details, so that you can enhance your skill set in the particular computation modeling. So 100%, as per my observation, the prediction says that for the next 10 to 20 years, the computation models play a very big role in almost all application in all domain. Okay, so that's the takeaway from this session. Thank you all the participants, and thank you all the members in the organizing team, because listening a lecture more than 20 minutes is almost, it is always boring. Okay, listening a lecture for more than 1.5 hours, I think it's really fantastic. Thanks to all the participants, and thank you organizers for giving this wonderful opportunity to talk about and discuss some insights about these future trends in this IT platform. Thank you, sir.
Dear participants, before entering into the discussion session, we will now have a photo session with our speaker. Kindly switch video on in your mobile or laptop.
Please, all of you join with us. Along with the resource person, we can have a group photo. Kindly switch on your videos. Organizers, please capture your photo by visualizing all the participants.
Pardon? What about my photo?
Some of them not.
Switch on your video, sir.
What about my photo?
Sir, we will now have a
Switch on
photo
your
session,
video.
sir, with our speaker. Kindly switch on your video, sir.
But you cannot start your video because the host is disabled. Host has disabled me. Yes. Very good.
Thank you. Thank you.
Thank you,
All
sir.
visible? All are visible?
Yes, sir.
Jivanandam?
Thank you.
ஜீவானந்தம்
very
சார்
much.
எல்லாமே விசிபிளா தெரியுதா சார்? கிரிட் கனெக்டர்ல தெரியுதா?
All the
Some of them
session.
not turn on the video, sir.
Okay. Can we wait some time or what?
Yes, sir. We will wait for some time.
You need to capture it from the all frames that is available on the top.
So in night mode, I think a few images are not good.
Yeah, yeah. We'll take on tomorrow also, sir.
Yes, sir.
Okay, tomorrow at what time?
Please see the schedule, sir. In WhatsApp, we have specified. Okay.
Okay, thank you very much, and good luck. Good night.
Yeah. Tomorrow we have around 6 hours of no, no, the session starts at 11. 11. The 11th session starts at 2 p.m. to 3:30 p.m. and session 12 starts at 3:30 to 5 p.m. Session 13 starts at 5 p.m. to 6:30 p.m. An online test and feedback will be conducted on 6:30 p.m. to 7:30 p.m. and final validity will be at 7:30 p.m. to 8 p.m. Sir. We have no mentioned everything in the WhatsApp. Please go through that.
Okay, thank you, sir.
Yeah, thank you, sir. Thank you.
Participants, please listen. Tomorrow we are having the last day of our ATAL FDP session, and kindly make sufficient data in your cell phone or laptop. Nearly 6 hours we are going to spend in internet.
Assessment test, sir. Hello.
Yes, sir.
What about the assessment test?
Yeah, that's what I told. No, entire program we have. I have to
Whether it
mention.
will be organized on FDP portal, the exam assessment test will be held on the portal or on mobile. Will you upload on the portal?
Yeah, yeah. I will tell you, sir. In that session 10, we will discuss everything.
Will you upload all your assessment test on portal or
Yes,
on
sir.
mobile?
Yes, sir. Yes, sir.
Link.
Atal portal itself.
Atal portal itself? Okay.
Yes, yes. Okay.
Yes, I want to confirm so that I can be ready on Atal portal.
Yeah, yeah. Portal we will include, sir. No issues.
Okay. Thank you very much. Okay, good night.
Good night. Good night. Thank
Good
you.
night.
Thank you very much.
Any participants you have any questions with the resource person, you can ask. I hope resource person is available.
Yes, sir.
Ravi Maran, sir.
Yes, sir. Yes, sir. I am available.
Yeah, yeah. Please, any doubt means you can clarify it for
Sure,
our
sure, sir. Sure.
participants. Participants, if you have any doubt, you can please ask.
The time is already 9:10. I think is. So one by one, they left the meeting. So
Okay,
I
sir.
think.
Okay, sir. We ended the session, sir.
Okay, sir. Thank you.
Thank you, sir.
Thank you. Thank you.
We sincerely appreciated for your insightful presentation and the valuable knowledge sharing with us, sir. Thank you.
Thank you, sir. Thank you, sir.